Today we will be solving inequalities containing absolute values. So let's take a look at our first problem here. Here we have the absolute value of x minus 5 is less than or equal to negative 2. So what we're going to do is we're going to isolate the absolute value. The same thing we did with absolute value equations. So now what we have is the absolute value of x is less than or equal to positive 3. I subtracted because they're opposite in sign. So let's think about our answers here. So x has to be less than 3. Well, remember there are two numbers that could go in for x. If we were just dealing with an equation, we would have negative 3, so the absolute value of negative 3 equals 3, and we also have the absolute value of positive 3 equals 3. However, we have an inequality, and the inequality says that the values of x have to be less than 3 or equal to. And so if you look at those numbers on a number line, if we start with negative 3 on one side, positive 3 on the other, to make values that are less than 3, we would have to have values that are bigger than the negative, but smaller than the positive numbers. You see, for instance, if I had an absolute value of 2, that number is less than or equal to positive 3, so that would be true. So it's all the values in between. And so that's the way we need to write the answers. We need to write it that way. So we're going to say that negative 3 is less than or equal to x, or x is greater than or equal to negative 3, and x is less than or equal to positive 3. So this is called an AND statement. And an AND statement can also be referred to as a conjunction. Conjunction is when two things come together, or a junction is where we have something coming together. Con means with, so they're going together, and that's what's happening here. So the values of x work with both inequalities. And you're always going to see that with a less than symbol. Let's take a look at another one here. So if I subtract 2 from all sides, I end up with this absolute value of 3x is less than 6. So when I go ahead and solve it, since I have extra work here, I'm going to set negative 6 on one side, positive 6 on the other, because those are the values that we want x to either be once we divide by that 3. We want the values to end up equaling that when we do the work inside the absolute value bars. Now notice that I'm going to have the inequalities kind of facing the same direction, but they mean something opposite. See, 3x is less than 6, but greater than negative 6. So when we go ahead and solve by dividing by 3 on all sides, I end up with this. Negative 2 is less than x, which is less than positive 2. And so it makes sense because you look at the inequalities, and the values of negative 2 are, well, from x, it is greater than negative 2, so it's going off in this direction. And from positive 2, it is less than. The values of x are less than positive 2. So again, that's the AND statement. So your answer is in the algebraic form and the graphical form there. So those are what we're looking for. Let's take a look at a different type of problem here. Here we have a greater than symbol. So first step is always to isolate the absolute value. So here I want to subtract the 2 from all sides. So I'm left with this x plus 5 in the absolute value bars is now greater than 6. So when I go ahead and solve, I'm going to do the same thing I had done before. So I've got negative 6 and 6. Those are my endpoints. X plus 5 in the center. But this time, x plus 5 is going to be greater than the positive, but less than the negative. Less than, because if you look at it, since the values have to be greater, if you're at, let's say, we'll go with just the negative 6 for now, but even though these aren't the solutions here. But just looking at those, the values of x have to be greater than those numbers. And so that means greater means this way. But when we're talking about absolute value, that means if we have numbers that are smaller than negative 6, like negative 8 or negative 9, if we take those absolute values, you see those are bigger than 6. So that's why we have the inequalities going in that direction. So we go ahead and solve. So now we're solving for the actual values of x that made that 6 or made that negative 6. And we go ahead and do that work, and we end up with a negative 11, and we have a positive 1. Now you're not going to write the answer this way because this is called an OR statement. An OR statement can also be referred to as a disjunction. So that means that the values of x don't work with both inequalities. if you look at it, if I graph this, negative 11 here, positive 1 here, open circles, the values of x are less than, because it points to the x, less than negative 11. But here the absolute values of x are greater than 1. So they don't work with both inequalities, it's one or the other. So the way you're going to write it is as x is less than negative 11 or x is greater than 1. So that's the way I want you to write the answer for just the or statements. With the and statements, you can write them as values in between, because they are in between. Well, the next one, again, you're isolating the variable here, and it looks like this is supposed to be a 7, so we'll go ahead and make it that way. So we'll put the 4 right here. We got their inequality sign already there. So we'll put the 4 right there, and we are subtracting it. And then from this point, I have this 2x minus 1 inside some absolute value bars is greater than 3. So when we go ahead and solve, we're going to set up our two problems. So right away, I know it's an or statement because it says 2x minus 1, the absolute value of that, is greater than. Greater means that it's going to end up being less than the smaller numbers, but greater than the bigger ones. So we go ahead and solve, and I'm doing opposite operations again. So I'm having to add 1 to all sides. So now I've got this negative 2 is greater than 2x, which is greater than 4. And so we go ahead and solve a little further. So I'm dividing by 2. And when I do that, I'm left here with negative 1 is greater than x, which is greater than 2. So when I go ahead and graph it, you'll see how the values of x are smaller than the smallest number for our two endpoints, but bigger than our bigger number. So we're going to write that as a or statement like this: x is less than negative 1 or x is greater than positive 2. So that's the way you've got to write those or statements. Here we have an and statement, and I know it's an and statement because it's less. Less means that it's going to be smaller than the bigger number, but bigger than the smaller. So that means that all the values are going to be inside. Since the inequality is already set equal to the absolute value, you can set that 3x plus 2 less than 11, but greater than, not greater than or equal to, but just greater than negative 11. So you can only do this once you've got the absolute value isolated. So we go ahead and do some opposite operations here. I'm going to subtract the 2 from all sides. So here's what I have at this time. I have negative 13 is less than 3x, which is less than 9. So I go ahead and solve by dividing by 3 on all sides. And I'll have my answer. Negative 13 thirds is less than x, which is less than 3. So this is an and statement. We'll put the negative 13 thirds over here. And from this point, I'll put the 3 over here. All the values of x are greater than that negative number, but less than the positive one. So they're in between. So another less than or greater than symbol this time, so that means it's an or statement. First thing to do is to isolate the absolute value. So that's a plus sign, so I need to take away, not subtract, not add, but take away 1/2 from all sides. So I'm going to take that half away from 4.5, and luckily that cancels out the fraction. So I got x plus 5 is now greater than just 4. And so from this point, we can set up our problem. X plus 5 is greater than 4, but less than negative 4. So I go ahead and solve by subtracting that 5 from all sides. And what I have left over is a negative 9 is greater than x, which is greater than negative 1. So again, all the values are going to be smaller than the smallest number, but bigger than the bigger number. So this is an or statement. And so all the values of x you'd write down are less than negative 9, or x is greater than negative 1. So or means, greater means or, less means and. Well, those are the types of problems you'll see on tonight's homework. Good luck.